In problem 2, we define the function capital F as the as the definite integral from 0 to x of f of t dt, and we're given the graph of f of t. The first thing that we need to realize is that we've defined an antiderivative of little f of t, so this is the derivative of capital F of t. So we're looking at the derivative of the function that we defined with the second fundamental theorem of calculus. So this definite integral, second fundamental theorem of calculus says that this function defined this way is an antiderivative of the given f of t. So the graph we're looking at is a derivative. We want to notice the things that we always notice about derivatives. Since f prime of t is positive, we can see that capital F is increasing. So since f prime is positive, capital F is increasing. We also can notice that f prime is increasing, so f is concave up. So also, since f prime is increasing, f is concave up. So we're going to look for a graph that is both increasing and concave up. Here are characteristics of f that we're looking for. F is increasing and f is concave up. It's important to note that I didn't say that f prime is increasing because f is increasing up here. That's just an unfortunate coincidence. So what we're looking for is graph of capital F is increasing and concave up. And only one of these graphs is it both increasing and concave up. The other thing to notice, if they wanted to actually challenge you a little bit, is to draw, they could have drawn two graphs that are both increasing and concave up. But there's another piece of information that we have. So notice that when we define capital F as the integral from 0 to x, we know one of the values of capital F. So we also note capital F of 0 is the integral from 0 to 0 of f of t dt. And regardless of what f of t looks like, that means capital F of 0 is equal to 0. So when we plug in a number here into a function defined with this definite integral, this is where the input goes. The 0 down here is just part of the definition. So all the graphs that you were given that you have to choose from here all start off at 0. So apparently they didn't care about that part of the question. They just drew the correct answer and then kind of 3 random answers, which is kind of weak in my opinion, but oh well, what you gonna do?
Can I ask a question?
Yes.
And why does the derivative not start at 0, but above this,
This is the graph that we were given. So that's just the question. So there's no why as to why it looks that way. That was just the question that they wanted to ask. If this is the derivative, then what does the function look like? But if we're looking for the answer, given this function, since capital F is the integral from 0 to x, that means capital F at 0 should equal 0. But this is the starting point. This was the question. Any other questions? Great, let's pause the video here and do some more problems.